This video is sponsored by LAP.
Hi, I'm Miles Budimir with Design World Magazine, and we're here with another installment in our Motion Control Basics series. This time we're here to talk about flat cabling. Flat cables are also used in some motion control applications. These cables can incorporate any variety of power, signal, and video conductors in a single compact cable. In addition to every type of electrical conductor, flat cables can also include tubing for air or liquids, and even fiber optics. By putting all of these elements into a single flat cable, motion equipment can be significantly smaller, quieter, and more energy efficient. Most industrial automation equipment today operates continuously with robots that execute rigorous motions repeatedly, sometimes thousands of times per day. These applications stress not only the moving parts of the machine, but also the electrical cabling. All too often, designers spend more time sizing components like motors, actuators, and controllers, and give little thought to the cabling needed. The result is that if standard cabling is used in these applications, the cables, not being designed to flex continuously, can't handle the rigors of the application and can result in costly premature failures. Flat cables are best for continuous flexing. Their wire conductors can individually flex in a single plane, which provides optimum flex life. Some motion control systems may encase separate wires, cables, and tubes in a carrier track to contain and manage the separate elements and to constrain their motion. These tracks are usually made of plastic, and they usually have a rather large bend radius due to their size and the rolling link element design. These tracks do not add performance to the motion device or machine, as they're simply cable management devices. Cable tracks can add bulk, mass, and inertia to the motion system, and moving this extra mass requires more energy. While certain motion systems such as robotic applications may require this type of cabling design, other designs may not and can use standard flat cabling instead to save cost and weight. Some flat cable manufacturers offer cables with silicone jacking. These types of flat cables are durable and need no external armor for protection. They resist abrasion and will even self-heal minor nicks. Silicone encapsulation also provides protection against oils, acids, ozone, steam, and extreme temperatures. When specifying flat cables in motion control applications, 4 considerations are usually key: the bend radius, life cycles under constant flexing, any packaging constraints, and environmental factors. The bend radius ultimately depends on the gauge of the wire and the kind of conductors used in the cable. As a general rule, the finer the conductor gauge, the smaller the allowable bend radius. Flat cables with PTFE jackets can have a larger bend radius than cables with silicone jacking, given that each cable contains the same number of conductors. For cabling used in flexing applications, 2 key factors are the wire conductors and the cable jacket. With continuous flexing, conductors containing multiple strands of fine gauge wire generally last the longest. Chief environmental factors include exposure to harsh conditions such as temperature and humidity, and resistance to environmental contaminants such as any oil or corrosive chemicals.